the way. Okay, the next example I'm going to have a look at here is this one here, where we have y equals ln root x. Okay, so somewhat complicated function. And what we have here that was a little bit different is we actually started by given the y value. So we want to know the tangent at the point where y equals, I believe it was -1. Okay? So this one here we have to sort of work backwards to find the x coordinate, which is a little bit trickier, particularly with this sort of function, I think. So our first starting point is we want to know what this x value is. So if I substitute -1 for y in, excuse me, I'm going to have -1 equals ln root x. Now the next step really to think about this is to really kind of understand what logarithms mean. The next step in order to solve this, you sort of think about ln root x. That means, what does e have to be to the power of to get root x? That's what ln means. If we think about the definition of it here, it's going to make the next step more obvious what we want to be. What does e have to be to the power of to get root x? And we've been told the answer is -1 already. So therefore, e would have to be to the power of -1 to equal root x. So just by thinking about the definition of a logarithm is the most simple way of going about that first step. Okay? If ln root x is -1, e has to be to the power of -1 to get root x. And therefore, to work out x, we now we square both sides. And if we square e to the -1, e to the -1 squared, we would get e to the -2. That's my 2. And that would be equal to x. Okay? So our start point is e to the -2, or 1 over e to the 2, if we want to go back to fraction notation, comma, -1. All right, so we've got our point. Now we need to work out what the slope is at that x value. So we need to find the derivative. So I'll make a little bit more room. Let's done that again, back to infinite canvas. That's probably going to happen every time. So now let's find the derivative. So if y equals ln root x, that's the same using the indice notation of saying ln x to the 1/2. Now, in order to find the derivative, we could, of course, use the f dash of x over f of x formula. We could go, we could do this. We could go 1/2 x to the -1/2 all over x to the 1/2. That's fine, and then we can go through and simplify that. But I think this is a good opportunity to use one of our logarithm laws to make it a little bit quicker and easier. So if I rewrote that as 1/2 ln x using one of my logarithm laws, I think it's going to be a little bit quicker and easier to find the derivative now. So dy on dx, we know the derivative of ln x is 1 over x, so it's going to be equal to the constant at the front now, 1/2, times 1 over x, which is going to be 1 over 2x. That there, if you use your indice laws and simplify it, is going to come to exactly the same thing. That's a little bit quicker and easier, in my opinion. They are the same. That, just highlight it so people watching the video, that there, once you simplify it using indice laws, is exactly the same as that. Okay? So, next step. We're going to use that same formula from the book to work out the equation that we did before. Just make a bit more room. Actually, I haven't actually worked out the slope yet, have I? All I've found is the derivative. So to work out the slope, I need to substitute this value. My x value needs to be substituted into my derivative to find the slope. So we are going to have 1 divided by 2 times by 1 over e squared. That's just substituting the x value there. And if we have a moment. Yep. So all I've done, I've just swapped the x for 1 over e squared. We can now tidy all that up, and that is going to end up being e squared over 2. So that is our slope. Now we whack it all into our formula of the tangent. Y equals the slope e squared over 2 times by x minus the x coordinate, which is 1 over e squared. And then we're going to have plus the y coordinate. The y coordinate's negative here, so it's going to end up being negative 1. And if we expand our brackets to get it in our final format, we're going to have e squared on 2x, there's our slope, minus e squared over 2e squared. And those e squareds are going to cancel out, leaving us 1/2. Make it 1/2, minus 1. So therefore, finally, e squared on 2x minus 3 on 2 is our final equation of the tangent. Okay, if I've gone too quick on any of those sections, you can watch back the video, or you can come and ask me to go through it in more detail anytime you like. Now let's have a look at that on the graph. Hopefully I've prepared that earlier. I think I called that one number 6. All right, so what we can see at the moment is our initial function, the ln root x, the green line there. And I have already put that point where y equals minus 1 on the graph. There it is. There's the point there where y equals minus 1. And the x value that we worked out over there, which I can remember what it was. What was the x value again? 1 on the e squared, yeah? Yeah. So obviously it's not exact here, but if you 0.14 is approximately 1 over e squared. Okay, we can do it more. Now to find the tangent there, I can just go up here, click the tangent button, and it will look like that. There's my tangent, which has the, I already had it up there earlier, but now it's up there twice. Y equals 3.68x minus 1.5, so we can see the minus 1.5 is the same as 3 on 2, which is consistent with our answer. And if we check that answer of what the slope was, which was what was the slope again? It was e squared over 2. If we went e squared over 2, it would be 3.68 approximately. Okay, and that is it. Are there any questions? We're good? Awesome.